3. Integrating expressions of the form x plus b to the power of your n. But before we go into this one, let's try to review first our derivative. If your y is equal to 3x plus 1 to the power of 4, how do we get the dy dx of this one before? We said we use the chain rule. And how did we use chain rule? So you have there now 4 times 3x plus 1 raised to 4 minus 1 is 3. Then multiply to the derivative of inside. And the derivative of inside is equal to 3. So therefore the dy dx then is equal to 12 times 3x plus 1 raised to the power of 3. Alright? Now, or in general, we said that if y is equal to ax plus b to the power of n, what did we do to get our dy dx? We said that is n times ax plus b to the n minus 1, right? Multiplied by your a. So what we're going to do now is the reverse of this. In here, we multiply, we put down the n, right? Then we minus n plus 1. We minus 1, I mean. In integration, suppose that you have the integral of ax plus b to the n dx. What shall we do? Again, in here we minus 1, but in integration, we need to add 1. So that is ax plus b raised to the n plus 1. In here, what do? We multiply by na. In here, we divide by a times n plus 1. And then you need to add your plus c. Please take note. Take note, this is a common mistake of the kids, that this one here is linear, meaning the highest power is equal to 1. So if, for example, you have a question like the integral of x squared minus 1 raised to the power of 4 dx, this formula cannot be applied here. Cannot, because the highest power of this is 2, but here it's not 2. So let's say, for example, the question is the integral of 1 over 4 minus x squared dx. Again, in here, we cannot apply that formula because the highest power of this one is 2. And aside from that, this is equal to raised to negative 1, which is totally different from this. Okay? Now, let's go to the example here. Example number 6. The integral of 4x minus 3 raised to the power of 5. Again, what we need to do is equal to copy the 4x minus 3. And then you add 5 plus 1. I think that's very thick. So that is now 6 over 6 times your a. Your a is 4. So this is now 4x minus 6. Why did I say minus 6? 4x minus 3 to the power of 6 all over 24 plus c. Okay? Now in this one, again, we have some strategies. So this one we need to rewrite first. Rewrite into 4 times 1 minus 2x to the power of negative 7 dx before you can take the integral. Alright? And please double check. This one should be a linear. Look at that, linear. Okay, if it's not linear, you cannot apply the formula that we're using here. So therefore, what do we know? Again, you copy the 1 minus 2x. Negative 7 plus 1 is negative 6. Then you divide this by negative 6. You multiply by negative 2. Take a look, why negative 2? Negative 2 because this is the derivative of this is negative 2 actually. Okay, so there's negative 2 there. And don't forget that we have 4 outside. The 4 just put there. Then you have the plus c. And then you need to simplify. Negative 12 times 2 is negative 2 times negative 6 is 12. So cancel, cancel. This is going to be 3. This is going to be 1. The answer is 1/3. The answer will be 1/3 of what? 1 minus 2 is negative 6, or 1/3 1 minus 2x to the power of 6. Okay? That is now our answer. Alright, example number 8. Now this one involves, what do you call this one? A radical. So 6 times 4x plus 9 to the power of negative 1/2. Again, take a look always the one inside. It must be linear. I keep on repeating, it must be linear. If it's not linear, you cannot use this one. Okay, so now you have there, copy the 4x plus 9. Negative 1/2 plus 1 is 1/2. You divide this by 1/2. And then the a there is 4. And then you have there 6. Okay, and then now you're going to have 4 times 1/2 is 2. You cancel this one is 3. So the answer is 3 times 4x plus 9 to the 1/2 plus c, which is equal also to this. Let's proceed to the next example. Again, there are only 3 ways that you need, 3 strategies that you need to look at here Number one is that if it is just in this form, I would say, let me just clarify this, okay? The first one is that if the integral is in this form, straightforward, apply the formula. The other one is if the question is in this form. Again, you need to rewrite first into ax plus b to the negative n dx before you integrate. The other one is that if you have their ax plus b nth root of this one, again, you still need to rewrite this one into the form of integral of ax plus b to the negative 1 over n dx. Or if, for example, you have like this one, nth root of ax plus b to the power of m dx, again, you need to rewrite first as ax plus b raised to the negative m over n dx. Okay? Again, before you apply the formula, check first if it follows this form. And check always the inside. It should be linear. Okay, linear. If it's not linear, this formula is not applicable. Try to look at and try to answer these questions here. How many more minutes here? I think let's try to discuss one problem here. What do you want to do? Okay, letter number 2. A curve passes through the point 1,5 and its gradient is this one. Find the equation of the curve. Again, the equation is y. So therefore, y is equal to the integral of 3x minus 4 to the power of 5 dx. So therefore, your y is equal to 3x minus 4 to the power of 6 all over 6 multiplied by a, which is 3, plus c. So y is equal to 3x minus 4 to the power of 6 over 18 plus c. Now, it is passing through 1,5, right? It is passing through 1,5. So therefore, 5 is equal to 3 times 1 is 3 minus 4 is negative 1 to the power of 6 over 18 plus c. 18 times 5 is what? 90? 90 is equal to negative 1 plus, sorry, again, I shouldn't multiply right away, but 5 minus 1 over 18 is equal to c. So therefore, this 5 times 18 is 90 minus 1 over 18 equals c. So 89 over 18 plus c. So therefore, just replace this one with 89 over 18. Okay, and that is now the answer. So for this one, guys, what you need to do is to take the integral of this. Then you're going to get this result, the second derivative, plug in the value of 6 and x. Then you will get the dy dx function. And integrate that again for you to be able to get the y. Plug in this one to find the c. Okay, so that's it for this video, and have a good day and goodbye.